Hi, everybody. I'm Dr. Catherine Holshoff. I want to take a few minutes to introduce myself and talk about why I'm teaching this course. So, I grew up in South Texas, in San Antonio. I didn't go to the best of schools or grow up in the best of neighborhoods, but we all knew that to get out, we had to be good at something. So, good at sports or good at school. I realized that I was better at school than I was at sports. And so I was accepted to the School of Arts and Sciences at the University of Pennsylvania in Philadelphia. My first a few years, I felt very underprepared for this experience. I had never left um, home before and was very overwhelmed. But as part of the federal work study program, I worked in the office of this couple that you're looking at. This is Doctors Dan Jansen and Winnie Howex. They had a major influence in my career because they invited me to Costa Rica each summer where they did their research. And that's where I studied and collected plants and butterflies. It was an amazing experience, and it introduced me to this fascination with diverse tropical ecosystems. But what I really wasn't exposed to at that time was, how do we understand these complex systems? How do we quantify and analyze these very complex ecological processes? It wasn't until I decided to pursue graduate school at the University of Arizona where I was exposed to the tools and the technologies that were needed to quantify complex systems. This is where I realized I had a fascination for quantitative ecology and quantitative theories like the metabolic scaling theory, which is what we're looking at. In this theory, for example, if you have basic data on body size or mass, then you can understand something fundamental about how life is organized across different taxa. And that was fascinating to me. It fueled my interest in R, programming in R, because at that time there really weren't a whole lot of openly available tools for analyzing large and complex data sets. You really had to have expensive software that, as a graduate student, I couldn't afford. And the software tended to be really hard to use, required a lot of training, and there wasn't a whole lot of support for the software. So that's how I got into R. After I graduated from Arizona, I spent a year at the University of California in Davis as a postdoc. This was where I was introduced to R user groups. These are self-organized groups that are located around the world, and weekly or every few weeks they get together and they have these coding sessions. And what I love about the art community is that it tends to be, for the most part, pretty inclusive and welcoming. And there's a lot of online tutorials and resources for programming in R. I was also introduced to organizations like Our Ladies Global, as well as the Carpentries, which we'll hear about later on. After California, I accepted my first faculty position at the University of Puerto Rico. It was great. I was a tropical ecologist, so living and working in the tropics was a unique opportunity. I had the chance to work with some amazing students and colleagues, and it was great until Hurricane Maria in September of 2017. It was a disastrous situation. I lost quite a few research projects, but overall we were fairly lucky. Our house was intact, and none of us were harmed. So after I decided to start a new leaf and new chapter here at VCU. I'm really happy to be a part of the VCU family and call Richmond home. Um, what I What I bring to VCU is my love for data science. And what I love about data science is that it's such an exciting field. Data science is the fastest growing industry in the world. It really allows us to be on the cutting edge. And there's no indication that this demand for data science has slowed in the past few years or that it will slow. Is predicted to continue growing. And I believe that the ability of ecology to solve major challenges relies on um, data science skills. What I also love about data science, in addition to having a solid foundation of theory, these are the types of skills that will set you apart when you're on the job market. And I'm really happy to be a part of VCU. I had my first baby last year. This photo was taken almost a year ago now. Look how cute that little baby is. Look at those cheeks. He is twice as big now and twice as demanding. So if you hear baby crying in the background sometimes in these videos, now you know who it is. Okay, I could stare at this photo all day, so let's move on. Let's get back to the science. So, what is data science? Data science is a combination of computer science, statistics, and business knowledge. As scientists, we are not trained in entrepreneurialism, but we should be. And the more time you spend with open science and open and reproducible tools, you'll start to see the overlap between data science and an entrepreneurial mindset. What I love about data science and the open science movement is that in many ways it is making science more accessible. The tools are open access and free. The data is publicly available. So, no matter where you are in the world, or whether or not you are financially or physically capable of collecting data on your own, you can participate in science. The data, the tools, the tutorials are out there and freely available. All you need is a computer and an internet connection. Data science is becoming synonymous with these beautiful data visualizations. This is how we communicate our data to the world. By the end of the course, you'll be able to produce stunning publication quality graphics that you can use to impress your advisor or to include in your manuscripts when you submit your papers. These are also the kind of graphics you expect to see in a publication, like in a science or nature paper. These are the types of graphics that you'll see in the New York Times, and I'll post. And feel free to share with us articles that use these beautiful visualizations so we can expand our design our eye for design. By the end of the course, you'll also have these marketable skills. The percentage of matching job postings that include R and data science or other programming languages has risen exponentially. And again, this isn't a trend or fad, this is here to stay. The types of jobs that require data science skills range across every sector you can think of, from policy to art and science. In academia, we're starting to see more and more job ads that require these data science skills. For example, the University of Michigan a few years ago now advertised for an assistant professorship of data science. Down the highway at the University of Virginia, they recently launched their Data Science Institute to meet this incredible demand. University of California, Davis also advertised for a research data scientist position. But these positions are not just within academia, quite the opposite. Organizations like EcoHealth Alliance are always looking for graduating students with data science skills. Conservation International just posted a position for a scientific programmer. Looks like my dream job. And more locally, an organization called Code VA works to bring computer and data science skills to K through 12 students. So this is evidence that it's in our own backyards, the demand for these skills. Data science, again, it's not a trend, it's here to stay. The demand and number of job postings is only going to grow, and it's much greater than the number of applicants. So by completing this course, you are strengthening your skill sets, and I really admire your persistence for pursuing these goals during this time. I'm really looking forward to working with you and learning new things with you in programming. I've been programming for 10 plus years, and I'm always learning new things. Oftentimes in these courses, the students will share what they've learned, and I'll learn along with you. So check out the rest of the welcome materials, and we'll talk soon.